Hi, in this video we are going to find the inverse of a 3 by 3 matrix. So the first thing that we're going to do, just like in our 2 by 2 matrix, we are going to change this little line thing because I am lazy and write the identity matrix next to the matrix we want to find the inverse of. There we go. And just like in the 2 by 2 matrix, I draw my line along the diagonal, and I am going to use the number on the diagonal right here to eliminate the 2 and to eliminate the 1. How am I going to do that? Well, I'm going to keep row 1 the same. Oops, let me move this over somewhat so that I can fit in my instructions. I'm going to leave row 1 the same, and what I'm going to do is for row 2, I'm going to multiply row 1 by a -2, and then I'm going to add it to my row 2. So I'm going to multiply every element along this row right here by a -2, and then add it to the corresponding element in row 2. So -2 times 1 is -2 plus 2 is 0. -2 and -1 is -3. -2 and 1 is -1. -2 and 0 is -2. 0 plus 1 is 1. And then 0 plus 0 is 0. How am I going to use row 1 to eliminate the 1 right here? I'm just going to subtract my rows. I'm going to say row 3 minus row 1. Okay, 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 0 minus 1 is -1. 0 minus 0 is 0. And 1 minus 0 is 1. Alright, so we have accomplished clearing the 0 points out of our first column. In order to make the left-hand side look like my identity matrix, I have to have zeros in column 1, both in the row 2 and the row 3 position. Alright, so once I have those zeros, now I can concentrate on clearing out the zeros above and below the diagonal in column 2. So I'm going to use that -3 to get rid of both of those 1s. So how am I going to do that? I'm going to multiply row 1 by -3. -3 row 1. Well, maybe not a negative. I'm going to multiply it by a positive. +3 row 1 plus row 2. And when I do that, I get 3 and 0 is 3. 3 and -3 is 0. 3 and -1 is 2. 3 and -2 is 1. 0 and 1 is 1. 0 and 0 is 0. I'm going to keep row 2 the same, so I'm just going to rewrite it. And then what I'm going to do is the same thing, but this time I'm going to multiply row 2 by a 3 so that when I add it to row 2, I get a 0. So I'm going to say 3 row 3 plus row 2. Alright, so 3 times 0 is 0 plus 0 is 0. 3 times 1 is 3 plus -3 is 0. 3 times 2 is 6 plus -1 is 5. 3 times -1 is -3 and -2 is -5. 3 times 0 is 0 plus 1 is 1. 3 times 1 is 3 plus 0 is 3. Okay, so now take a look. Column 1, I have zeros in the right spots. Column 2, I have zeros in the right spots. Last is column 3. So I need to figure out how I'm going to use this 5 on my diagonal to zero out both the -1 and the 2. So I'm going to squeeze this in here. Hopefully we can do it. So for row 1, I am going to multiply row 1 by a -5. negative 5 row 1, and then I'm going to multiply row 3 by a 2, and I'm going to add those together. So this is going to be negative 15 plus 0 is negative 15. I'm going to have a 0 and a 0, that's 0. So then I get a negative 10 plus a 10 is 0. I get a negative 5. Yep, a negative 5 minus 10 is a negative 15. I get a negative 5 plus 2 is a negative 3. I get a negative 5 and 6, or I mean a 0 and 6 is 6. Row 2. How do I get that 0 there? Well, I'm just going to multiply row 2 by 5 and just add row 3 to it. So 0 times 5 is 0 plus 0 is 0. Negative 3 times 5 is negative 15 plus 0 is negative 15. I get a negative 5 here plus 5 is 0. I get a negative 10 here minus 5 is a negative 15. I get a 5 and a 1 is 6. I get a 0 and a 3 is 3. And now I'm not changing row 3. So now if you notice, our matrix is almost done. We've almost converted the left-hand side to the identity matrix. The last thing I need to do is just divide by the numbers along my diagonal. So I'm going to take row 1 and divide it by a negative 15. I'm going to take row 2 and divide it by a negative 15. And I'm going to take row 3 and divide it by 5. And when I do that, I get a 1, a 0, and a 0. I get a 1. I get a 1/5. And I get a 2/5, or a negative 2/5. When I do the same thing in row 2, I get a 0, a 1, a 0, a 1, a negative 2/5, and a 1/5. And in row 3, when I divide, I get a 0, 0, 1. I get a negative 1, a 1/5, and 3/5. Okay. So what part of this is my inverse matrix? The right-hand side. We transform the left-hand side into the identity matrix, and my inverse of the original is 1, 1/5, negative 2/5, 1, negative 2/5, 1/5, negative 1, 1/5, and 3/5. And on the screen I don't have enough room to check, but if you wanted to check, you could multiply this original matrix right here by the inverse, and if we did everything right, we should get the identity matrix.